In 8.4, we're solving when we have exponents with unlike bases. For example, in this first example, we have, what is the solution of the equation 3 to the x equals 17? Now, there's no way that we can make 17 have a base of 3. So, when this is the case, we want to put this equation, 3 to the x equals 17, into not exponential, but log form. So we would have log base 3 of 17 equals x. Now, I'm going to plug that into my calculator. Remember, with our Casios, we actually have a button for that. So math log, our base is 3, 17. So x is approximately 2 6/10. So there's our first example. So our next example, solve 4 to the x equals 19. So once again, we're going to put this in log form. Log base 4 of 19 equals x. Then we can plug that into our calculator. So log AB base 4 of 19. So x is approximately 2 1/10. In this example, now we have a little bit more. So we're going to start the same. So log base 7 of 40 equals x minus 2. Well, now x isn't by itself. So we need to move that minus 2. We're going to do that like we normally would, adding 2 on both sides. So log base 7 of 40, and I'm going to put it in parentheses so the calculator knows that I just want the log of 40, and then we add 2 equals x. So now when I type that in, log base 7 of 40, make sure to move outside of those parentheses, plus 2. And that would round to 3 9/10. So x is approximately 3 9/10. This one is a little different as well. Now, the key difference here, before we have this 3 to the x, there's that 3 in front. So we first need to move that to the other side. So I'm going to subtract 3. So now we have negative 3 to the x equals negative 25. Now whatever has our exponent on it, we want to be positive. So to get rid of that negative, divide by a negative. So now we have 3 to the x equals positive 25. And from here, it's just like all the other ones we've been doing. Log base 3 of 25 equals x. Now x is by itself, so we can plug that into our calculator. Log base 3 of 25 is approximately 2 9/10. Okay, one last example. What do you think the first step on this one is? Right, so our first step here, because there's more on the same side of that 4, which has our exponent, we need to move 7 to the other side. So 4 to the x plus 1 equals, that's a 7, 276 equals 274. And now we can write it in log form. Log base 4, 274 equals x plus 1. X is not by itself here, so we want to subtract 1. So log base 4 of 274 minus 1 equals x. So now we can plug this in our calculator because x is by itself. Log base 4 of 274 minus 1. We get x is approximately 3.0. Now, I know you don't all have these Casio calculators at home, so just a reminder, at home, we could type this in as log of 274 over log of our base 4, then minus 1. So just to show you that we would get the same thing, my fraction log of 274 over log of 4 minus 1, minus 1, and I still get that 3.0. So that is solving with unlike bases.